Welcome to the Professional Data Engineer Crash Exam course. Today we will focus on Dataflow, a unified blueprint for stream and batch processing service. Dataflow uses a unified model based on the APACHE BEAM SDK to handle both batch and stream processing. This is managed by an automated infrastructure featuring horizontal autoscaling and cluster management. The Dataflow environment is structured with worker resources, a streaming engine, and Dataflow Prime, which utilizes data compute units. Billing is per second and per job. The Dataflow backend service includes Dataflow Shuffle, streaming engine, and state storage. This offloads heavy storage and shuffling from worker VMs, improving execution and reducing latency. Dataflow uses standard horizontal autoscaling to adjust worker instances based on load. Dataflow Prime introduces vertical autoscaling, dynamically adjusting worker memory and CPU, preventing out-of-memory errors, and optimizing resource utilization. The core concepts of a Dataflow pipeline are the pipeline, which defines the process, pipeline I/O for source and sink interaction, PCollections, which are distributed datasets, and PTransforms for operations. Key PTransforms include Pardot for parallel processing, cogroup by key for relational joins, and flatten to merge multiple PCollections into a single stream. Graph optimization improves efficiency. Fusion optimization prevents data materialization between steps, saving memory. A reshuffle transform can be introduced to force steps to run as independent parallel stages. When dealing with continuous data streams, a key challenge is the difference between event time, when an event occurred, and processing time, when it is processed by the pipeline. Windowing strategies are used to divide continuous data. These include the fixed-size tumbling window, the overlapping sliding window, and the dynamic session window, which is gap-dependent. The watermark is the pipeline's expectation of the oldest unprocessed data, tracking completeness. Late data arrives after the watermark passes. Metrics like data freshness and system latency monitor performance. Triggers determine when results are emitted. The default is "after watermark". Other triggers are based on event time, processing time, or data volume. The rule of lateness allows triggers to fire again for late data. Windowing output can use accumulating mode, including all data since the window opened, or discarding mode, only including new data since the last trigger. The with allowed lateness boundary defines how long to wait for late data. The four steps of stream processing are the window, which contains the data, the watermark, which tracks event time, the trigger, which dictates emission, and accumulation, which refines the output. When using pub/sub as a source, temporary subscriptions should be created for isolation and backlog prevention. As a sink, use windowing and watermarks to manage unordered messages due to pub/sub not guaranteeing message order. Dataflow supports exactly once processing by assigning unique message IDs to outgoing data. The Dataflow engine handles complex atomicity through streaming transactions. Downstream systems must use idempotent sinks to discard duplicate messages based on the unique IDs. Error handling in Dataflow uses a side output to direct failing messages to a dead letter topic. This allows for later analysis of errors without halting the pipeline or dropping data. Dataflow can operate within a shared VPC host project for centralized network management. Workers must operate without external or public IPs, relying on private Google access for secure connection to Google services. IAM roles define user access, from Dataflow Viewer to Dataflow Developer and Admin. Service accounts, like the Dataflow Service Agent and Worker Service Account, are used for job creation and data access. CI/CD procedures for live streaming pipelines allow for minor changes using a live update mechanism, switching data dynamically without downtime. Major changes require a stop-and-replace action, using the drain option for graceful processing of in-flight data. Dataflow provides a robust architecture for data processing. It leverages automation and optimization for efficiency. Thank you for watching this video on the Dataflow Architecture Blueprint.